Doctor, you are muted on YouTube. Yes.
What about now? Can you listen to me in,
Yes, doctor.
in YouTube? Can you listen to me on YouTube? The one who was saying that he can't listen to me through YouTube. Can you listen to me right now?
Yes, we can listen to you.
That's good. So the YouTube, I believe, is way better in terms of resolution than Google Meet. The Google Meet is used by a lot of people nowadays, and it's crowded. There's some.
Doctor, I listened to you twice from YouTube and Google Meet.
You better open one. Sorry, Majid. Yeah. You, if you prefer, the problem with Google Meet, you can't talk to me then. You got the idea. And I can't open both of them to read your chats there or listen to you. I That's the reason I'm using Google Meet as well as YouTube channel. Why I'm using YouTube? Because I want the lectures to be available to you all the time. You can watch them anytime you like. For this lecture, it's not very important lecture. This is just an introduction, me knowing you and knowing each other. So let's start describing the course. The course is not a new course. It was offered some time ago by an instructor called Isa Al Hussein. He's the director of Earthquake Monitoring Center. So he might be more suited than me teaching such course. But the good thing that my specialization, I did my PhD in something which is very related to earthquake. It's not exactly earthquake. I just recently graduated, did my PhD. So I'm back to the universities after 5 years doing my PhD. So I have some like energy and I would like to make some change to the department. Our subject geophysics having some troubles nowadays. The number of students are decreasing. My plan is to make it enriching again, attractive to the students, and make change that might be useful for both the faculty and the students. So as I said, my background is geophysics in general. I did my undergraduate in the SKU. I graduated in 2010. Then after that, I did some like demonstrating in SKU for 2 years. I did my master later on. After the master, I did my PhD. My master was in geophysics too, but in something more complex, in seismic inversion. You don't need to know these terminologies. I know some of you even don't have any background about geophysics. What is geophysics? I promise the course gonna be very simple. We'll not go to like advanced calculation or advanced theories in geophysics. Those advanced things, they are even not at the level of graduate students here at SKU. Those advanced courses like inversion, geophysical inversion, they are taught in graduate levels. Once you do your master degree or PhD degree, then those are the courses more suitable to teach seismic inversion or waveform tomography or something very advanced. So in this course, we try to be as simple as possible. The course code is 3,000. So it's supposed to be taken by students who are in their third year or second year in SKU. For that reason, it's supposed to be very simple and very attractive. So we are not targeting geophysics. We are even targeting non-geophysics. Another aspect, earthquake in general is a hot topic and supposed to be understood not just by geophysics, but even non-geophysicists. So you need to have some background about how the earthquake happens. What are the many terminologies behind earthquakes? What are the after effects of earthquakes? How we can deal with earthquakes? So those are some topics we try to encounter in this course. But I studied this course. I was a student in this course. So I want to make a deviation, a slight deviation. Why? What I mean by deviation is that instead me asking you to memorize historical earthquake, when they happened, how many people died, and what was the cost in terms of damage caused there, what was the cost in terms of damage in certain parts of the earth. But let's go make it more technical a bit, something you might benefit from. Either you are geophysicist or non-geophysicist. You as an engineer, I'm seeing a lot of engineering students. This is very interesting thing. And I'm seeing also geophysicists and earth scientists. You as an engineer or a scientist, you need to know some like technical part. And those technical part, they are not only related to geophysicists. They're supposed to be known by even non-geophysicists. So you might see there the caption are always on. This feature will be on either I'm using Google Meet or using PowerPoint. The same feature is available in PowerPoint. So I'll make it always on. In case I'm not pronouncing something right, I'm sorry about that. But in my view, what's written there is a bit about correct. That's a good like feature there. So whomever is not knowing what I'm talking about, if you open Google Meet, you'll find that whatever I'm saying, they are written there in English. Is it fine? Can you listen to me? Hello? Guys?
Yeah, yes, we are you.
Okay, good. That's good. Thank you, Anwar. I thought I lost connection.
Yeah.
So back to the course. The course is a graded course. It has
Yes. We can hear you.
It's a graded course. So it's the good thing. It's not 2-hour course, or the lecture time is not 2 hours. It's I believe 1.25 hours. Am I right? So we start by always 4:15 and we finish by 5:30. So it's 1 hour and 15 minutes about. It's short course, short time course. For the lab part, I tried to make it very short even, but we grasp all the idea through the lab. So in terms of evaluation, that's something very important, and we are in very a pandemic period. You cannot attend the SKU. I'm following the normal regulations we have. The regulation says that the final exam is supposed to be 40%. So the final exam right now is 40%. But we have quizzes. We have practicals, and the practical are the same, the one you do during the lab session. Usually I ask you to submit something by the end of the lab, or 1 hour or 2 hours after the lab, if you cannot finish during the lab itself. And we have an interim exam. The interim exam, I believe I made it on week 8, but still it's subjective. We can change it if you find that, because this is an elective course, the priority always given to your core courses. So if the final exam is conflicting with the time you have with another exam, I'm fine changing the time to some different time. But the exam will be conducted during the lab time on Tuesday. Whenever we have a quiz, the quizzes, they're gonna be conducted even during the lab session. So during those days, the lab, there might be very short lab, or might either no lab on those days. But for evaluation, exams and quizzes, especially exams and quizzes, no practical, they will be separate. But as I said, exams and quizzes, they're gonna be conducted on what is this, the Moodle, sorry. They're gonna be conducted through Moodle. So the evaluation system there is way better than we can use even Google Meet, but I'm more comfortable with Moodle. So the exam and quizzes, they will be conducted through Moodle itself. What are the course content? So we have about 6 or 7 chapters. There are 7 chapters. So each chapter we're supposed to finish it in 2 weeks. So we have about 14 weeks. The last 15 weeks is a review week. There is nothing new I give to you the last week. So we have 7 chapters. We have total of 14 weeks. In each 2 weeks we finish a chapter. The chapters, you might think that the topics are quite complicated. No, I try to simplify them as much as possible. For example, the first lecture gonna be about earthquakes in general. I believe many of you have already taken Geology 1 or Geology 2. Some of you have taken even general geophysics, and you understand what are the faults, what is a fault, and how the faults are generated, what the outcomes of faults. Whenever there is a big fault, there is an earthquake as well. And we'll talk about the internal structure of the earth. You know, they just recently discovered the earth's internal structure, and the main the technique they used to discover the internal structure of the earth, those were earthquakes. The earthquake data, these were the things, the information they used to discover what is the earth is made up, how many layers it has. In terms of layer, I'm not talking about sedimentary layers, no, big layer, the crust, the mantle, the core, and the velocity, the wave. Whenever I'm hitting something, this hit, you listen something. Those are waves, by the way. So the wave can travel on air, the wave can travel on different materials, they travel on wood, on rocks. The speed is different. The speed by which the wave travels is different. So from the differences in speed and the differences in travel time. What I mean by travel time, when I hit something, you might listen it after some time. So that's the travel time. What do you think is faster, the voice sound or the lightning? Basically, the lightning is faster. That's the reason whenever there is a lightning, you see the lightning and you hear the thunderstorm right after like a minute or half a minute. So this is the travel time, the velocity by which the waves travels in rock. And we'll talk about these things. Another point, we do a lot of practicals. Whenever we do practicals in geophysics, there is some difficulty if we go through the math part itself. The math is not easy in geophysics. So we try to avoid the math. How we can try to avoid the math? We try to deploy those mathematical equations without going to the details, how they are made. Because you are not mathematicians, you are engineers and geoscientists. For you, you need to know how to apply those techniques, mathematical techniques. So in this case, starting from next Tuesday, I introduce you to an application or a package called OpsPy. It's built on Python. Python is a programming language. So we use Python. Don't be afraid of using a programming language. It's a very simple programming language, and we use it just to deploy things. I'm not asking you to create some new functions or new theories or new mathematical formulas and write them in Python. No, I ask you just to use things which are already available in Python and come up with results. See what are the earthquake signals we receive. Signal is a waveform or موجة in Arabic. So how we can see them, how we try to interpret them, these are the things we can achieve through an application or a package called OpsPy. The package name is OpsPy. It's built by other people's, and we just need to use it and deploy it in our case. And the next lecture, since we are talking about earthquakes, you need to know something about stress. Stress, in terms of stress, rock has stresses as people has stresses too. You might get stressed sometime, am I right? So whenever you get stressed, take a break and come back. And the stress is associated with strain. Whenever there is a stress, there is a strain. A strain is the change associated with the stress. Whenever you are under stress, how some people knows that you are under stress? يقول لك شخص انت يا اخي كأنك ما طبيعي فيك شيء. How he knows? He knows by your, for example, your face color, your expressions. So those are the things he might, through them, knows that you are under stress. The rock, they behave similarly. If they are under stress, their shape changes, they act differently. So through strain, we know that there is some stresses going through the rock. And since we are talking about stresses and strain, we go through a lab. In that lab, we do Mohr circle. So this is my pen. If I keep stressing, keep bending it, would you think that it keep bending forever? No, at some point it will break. That pen gonna break at some point. This is the stress I apply. The change, you see that there is a change. I'm seeing some bending. That's the strain associated with this pen. So at some point it will break. So in that lab, we try to determine what is that point, how much force I need to apply to break this pen. But we don't apply it on pen. We try to make that lab on rock samples, but not real rock samples. We use some software or some lab techniques just to analyze when exactly the rock fractures, when the rock breaks. Because at the point when the rock breaks, what happens? There is an earthquake. We go back to our topic, our lecture, what is earthquake. So we talk about strain and strain. Then we talk about seismic phases or seismic wave types. Some of you are taking the general geophysics course. I saw from the names right now, concurrent with this course. So the seismic waves, they travel in different forms. Those are the phases. So it has different velocities. The rock itself has different velocities. So we try to understand those velocities. What are the different velocities within rocks? How the rock behaves whenever there is a waveform traveling through it. So those are waves. I might think that you already have some idea about that. Maybe through general geophysics, or maybe from other courses like Geology 1, seismic waves. In earthquake seismology, the waves are more complex. So we will not deal with all the wave types. We will deal with the most important wave types. But we use OpsPy. OpsPy, I'm sure that you will enjoy using it, because you can see the earth structure, you can see the wave types, you can see the waveforms. What is a waveform? No, we'll keep it for later on. But for the time being, you can display those waveforms. You see how the wave are traveling through OpSpy. Again, I'm not asking you to be a perfect in Python. No, I will never ask a question how something is written in Python. I never even ask a question, either in exam or even in labs, create some function for me in Python. No, I ask you, use some application which is available in Python and deploy it for your use case, whatever homework you have. So there is another lab we have whenever we talk about seismic phases. Picking. You pick the start of some wave type when that wave arrives. So whenever I go back to the same example, whenever I hit this board, I keep hearing noises. I'm sitting nearby and someone sitting far away from me, you might reckon that me will be listening to the voice or to the noise my hitting creates first. That's true. So I'm supposed to pick it first because I'm nearby. The one sitting far away from me, he will be picking the wave later. So you will be doing some picking. The first lab will do picking manually. So you, by visual inspection, see some waveform. Again, what is waveform? Have you seen a sine wave? A sine wave. I believe you have seen already a sine wave. You have done physics 1, probably physics 2, or even in your school time, high-level school. You know what are waves. Those waves, we call them usually also waveforms in geophysics. So you inspect those waveforms, try to determine when the signal arrives, when this sounds from the earthquake, this energy from the earthquakes arrives and reaches to some point. During that case, when we were talking about earthquake waves, we'll deviate slightly and talk about instruments. And for this simple example, what is the instrument? How I can hear to the noise I make is my ear. But for geophysics, to listen to those earthquakes, we need equipment, special equipments. So those equipments are the one which picks the waveforms generated by earthquakes. So we'll try to see how they are made of, what are they, and how they record. So we have seismograph. That's the equipment. I believe you have heard of seismograph. That's the equipment which measures or records the earthquake, and the seismogram. The seismogram is the signal recorded by the seismograph. Then we try, because this is a very interesting topic, where the earthquake happened. How they know? How they know exactly nowadays where exactly an earthquake happened? They say an earthquake happened at a specific location in Iran, in some places. Nowadays, the instrument, the instrument I was just recently talking about them, they are very, very sensitive. Even a small earthquake which happens in head, they can be recorded by an instrument located in US. So this is very interesting. And we'll see about the network we have. So the Earthquake Monitoring Center in Oman, it deployed a lot of earthquakes, a lot of instruments. So we'll talk about the network we have in Oman, and also how it was integrated with the network UAE have and Iran have. So we are working in collaboration with them. So to get a bigger network, record even the tiniest earthquake. And whenever I talk about earthquake tiny, there is something then comes to your mind. How you know that this earthquake is big or small? That's something called magnitude, and that's chapter what? Chapter 5. Chapter 5. So locating, we'll do some exercises in locating. So I give you some records, some seismograms. Seismogram, they are generated by the same earthquake, and you try to find where exactly the earthquake happened. We use first, for the first lab, we do it manually, just simple one velocity, because you need two parameters. You need the time, you need the velocity. Once you know the velocity and you know the time it arrived, you can predict from where it came. So this is a technique, simple technique. Then we use a software. We use Python software, OpsPy again. So through OpsPy, we try to find exactly where the earthquake happened. We try to, even if there is a chance, to analyze the uncertainty, if we have chance, if there is a time. So whenever they say there is an earthquake somewhere, you might ask how sure you are that it happened exactly at that location. So these questions bring uncertainty. You say how sure you are. So there is something called probability. You say, oh, I'm 50% sure that there is earthquake at that location, or 100% sure that exactly at that XY location on the surface of the Earth. So this is about locating earthquakes. And this is another topic, but nowadays, like earthquake seismology got interest even in companies like PDU and BP in Oman, especially. It have found great applications nowadays in Oman. You might ask, how come that then? You as petroleum engineers, I might ask you, if the rock is very tight, if the rock is very hard, and you cannot produce from it, what you supposed to do? Can someone answer me? Oh, I forgot to say something.
Fracture.
Yes, doing some fractions.
Fractures, we do fracturing. So fracturing job. They come along, they try to fracture the rock and open some pathways or open some pores to let the fluid flow. So there is another thing. I said before that I'm not asking you to attend. That's true. But I'm not seeing you. I wish that I can see you. You can see me at least. But you, from next week, whenever I'm giving the lecture of the theory part, I will be sitting in front of a whiteboard. There is a whiteboard in here. This is my office. It's a small office, but it does suffice me. So this is a whiteboard. I probably use this one or go to another room. So I might put my camera here and change the setting. How you can change the setting? I make my screen way bigger, occupy all the screen, so probably you can see way better. Yes, I can bring it here, so you can see. You already have I give you the handouts. You're gonna have the handouts, and me will be sitting there or standing in front of the whiteboard and talking. I'm planning also to buy a projector. I'm not sure is it necessary or not. So nowadays the projector, they have remote control. I can switch it on or off right away from the remote control. So whenever I'm trying to write something, I switch off the projector. But whenever I'm explaining something on the slides, the projector gonna be on. Okay. My experience, sorry to deviate again, but we finish earlier. I promise you finish in quarter an hour. My experience, I taught before general geophysics. I got very good feedback from engineering students. they are not saying that College of Science students they are weak. They are also excellent students. But I found that the students from engineering they trouble you. they ask a lot. But I enjoy that. I really enjoy that. I want the same enthusiasm I have observed before from engineering students. They ask a lot. They keep coming to you. They visit you a lot. They send you email at 4 o'clock early morning. I said, come on, who is awake at 4 o'clock? Why are you sending me an email by 4 o'clock? But this is how is it. But I remember that was like 5 years or 6 years ago when I was teaching general geophysics. And general geophysics is a mandatory, a core course for the petroleum engineering students. So I would like to see the same behavior again, not just from petroleum engineering, even from all of you. Again back, so then we, as I said, how you can define the earthquake is big or small? It's based on something called moment magnitude, or magnitude in general. Can somebody tell me a type of magnitude you often hear about in the media?
Richter, meine ich.
Richter. Yes, perfect. Thank you. I wish to give you one mark. But that's what I was talking about. So I'm not seeing you, but next week onward, I bring a mug, I put your names, I pick a name randomly and ask a question to that particular person. And if he answers correctly, I give like half a mark. So this is a good chance you attend the lectures and try to answer my questions. I pick randomly. The one I pick, his name or her name, I keep it aside for the for 5 or 6 lectures, more lectures. This is just for the purpose to give chances to everybody. But I will not ask once. I ask 2 or 3 times in one lecture. So I hope everyone get a chance to answer a question. Don't be shy. I'm seeing that everyone is already energetic. This is good point. So we talk about magnitudes. And we try to find their different magnitude types. The one you right now talked about, Richter, is only widespread in media, but among geophysicists it's not very popular. So geophysicists, they know that the Richter magnitude is not a representative magnitude. There is another magnitude named the moment magnitude. It's more representative of the 2 earthquake scale, or the energy earthquake generates. By the way, we'll come back to this point again. Magnitude is not necessarily associated with the damage associated with an earthquake. So the magnitude, you cannot say, oh, this is a big magnitude, it's supposed to have made much more damage. No, that's not true. If an earthquake, a big earthquake with a high magnitude happened in a rural area, in some place which has no inhabitants, that's a good thing. No one dies, nothing damaged. But a small earthquake happens in some place highly populated, and the building there, they are not strong or cannot stand earthquakes. There are a lot of damage and collapses and even fatalities probably. So we'll talk about how we define magnitudes. We'll not go through the equations a lot, but again, the OpsPy package through Python, we'll use that one to try to find what is the moment magnitude of certain earthquakes. How we can find what is the magnitude of earthquake. You know, one good thing about OpsPy, you can get earthquake happens very long time. Yani not the earthquakes themselves, but the data which recorded those earthquakes. You can simply get those waveforms and you can analyze them. And we'll do that. We'll do that. I'll show you some examples through some handouts. Then you do it through homeworks. This is how the homework is scheduled. So there are some homeworks. How much they account for? The homeworks, where are these grading scheme? Oh, where is this grading scheme? Yes, the homeworks, they account for 20%. Practical, the lab part itself, they accounts for 20%. Midterm is 20%, final exam is 40%. I'm flexible in terms of you say we can change the midterm exam time. But the timing for quizzes, we have 3 quizzes. We have four practical, 4 homeworks. 3 quizzes, 4 homeworks. 1 midterm exam, 1 final exam. So after magnitude, we go to something called source mechanisms. What is source mechanism? They even call it focal mechanism. So whenever there is an earthquake, the earthquake might have just made a strike slip fault, or a normal fault, or reverse fault. This is what is known as source mechanism, or just an opening, Let's say again, there might be a normal fault, a strike slip fault, or an oblique. Oblique is a combination of either strike slip and a normal fault. So that's an oblique fault. You already have studied Geology 1 and Geology 2, I believe, so you might have an idea about what is fault. If you don't have, we give you a review about the fault types again during the next lectures. But I ask you again a question. That might be the last question I ask for today. I said maybe there is an opening. When you think an opening happened, I said a fault, an earthquake, which was an opening. Who can answer me?
Yes, doctor. Can I answer?
Sure. What's your name again? Hamid?
Yes, Hamad Ramadani.
Yeah. What do you think?
I think the opening fault is happening when the tensional movement of tectonic plates.
You think they are moving apart?
Yes.
That might be a normal fault. They are moving, it creates a normal fault. It's more often associated with a normal fault. Someone else? Who can answer? Get the courage. No problem, no idea.
I think that related to the magnetism.
No, at all. But good thinking. Not at all. It's related to fracking. Have you heard of fracking? Yeah, some people just answer it. Fracking. I said earthquakes are becoming more like interesting for all companies. So whenever they frack, they create opening. Am I right? How those opening happens? This is a fracture or a small earthquake in the rock. Small earthquake. So my PhD was simply try to find and characterize those small earthquakes. They're called micro earthquakes or microseismic. So it has a lot of application nowadays in PDU, in other companies working in Oman, because they're doing a lot of fracking jobs. And believe me, all the analysis, they are not done by Omanis. They are done by foreigners. Not even in here. They send the data to some external company. They do the analysis, they do the interpretation, and just return the final data to the PDU to make the decision based on their analysis and recommendation. Not just PDU, even other companies working in Oman. So this is a hot topic in terms of like knowing the source mechanism, knowing how the fault happens, because the same idea you apply for big earthquake, it's applicable for small earthquakes. By the way, when I talked about magnitudes, what is the biggest magnitude you heard of? Who can answer me? What is, in terms of size or the number, what is the biggest magnitude you heard of?
San Francisco, I think.
Without mentioning the names, like, do you remember the Sumatra earthquake just happened in 2004 or 3? And we were smart.
Yes.
Yeah, that earthquake had a magnitude of 10. It's one of the biggest magnitudes. So this is 10. And earthquake magnitudes, they can be in minus. So -4, -2. So my case, my PhD, I was looking to the magnitude scales below 0. Those are in oil industry. So there were small fractures or small opening. And there were thousands of them. Thousands, not 1, 2. And this is called Richter Gutenberg scale. What I mean by that? Whenever the earthquake magnitude increases, their frequency decreases. You got my point? I mean, whenever there are a lot of small earthquake right now happening, the earthquake we feel as a human, or we can feel as a human, supposed to be above 3. Above magnitude 3 for a human to feel. If they are below 3, we cannot feel it. But geophysical instruments, they can feel even, some of them very sensitive ones, they can feel even magnitude below 0. So what I mean by this power scale is that whenever the scale of that, or the size of that magnitude increases, their frequency, the number of times they happens, decreases. So there are very few earthquakes which are above 5 or 6. But there are millions of small earthquakes we even can't feel. So once we are done with the source mechanisms, the last topic is how we can predict. Is there a technique we can predict when the next earthquake happens? Is it possible or not? So this is one of the topics we will deal with. And since there are some students from engineering, we try to scratch the surface of some civil engineering. So this is not from geophysics, but civil engineering. We try to combine many things. How we can design the buildings so they can withstand some earthquake. How the Japanese are living a life. I was in Japan once. So in hotels, you will find that there is a small notice saying, in the case of an earthquake, don't panic. Because those buildings, they can stand earthquakes. So we try to understand how we can design, how those buildings are designed to withstand some earthquake. And does Oman has this code, they call it a code, earthquake building code. So does UAE just recently made this code. Oman just still working on the same code to build it for Muscat area. Turkey made it because Turkey has a lot of earthquakes. It's an area where it's very prone to earthquakes. UK, for example, does not have it. UK, most of the buildings in UK, they are not, they are very susceptible to earthquakes. In case if there is an earthquake, certainly they're gonna be damaged. But yeah, that's an interesting topic. If we get time, we talk about how we can design those buildings, how they are designed, not necessarily how we design them, but how they are designed. And what is this code I was talking about? It's not a programming code, it's a code, okay, if your building is like that in a certain area, so it can stand an earthquake of a magnitude, blah, blah. So we have 10 minutes, let's say. I'm waiting for any questions or anything you have. I hope I gave you an idea about the lecture or the course contents. And you have right now, good idea how whether to stay with the course or find a substitute, because this is, you know, this is an elective course. You try to find what's more important or what suits your needs in terms of electives in geophys in SKU. And it's good idea also to find a course which is not which does not make you overloaded. It has no, so we can be even more flexible in terms of like reducing the number of quizzes or reducing the number of homeworks. But by the end, you're supposed to graduate with some, or finish this course with some understanding of the basics of earthquakes and how they affect the society. Any questions? So again, the lecture gonna be available on always on YouTube. You can, I'm streaming on YouTube, so it will be available on YouTube to watch anytime you like. The theory gonna be in a lab most often. The lab part, the tutorial part will be in the same setup right now. I will be sitting in front of my desk doing some coding, not simple coding like using Python or something, and showing you how to do the same thing. Any questions so far? There was a lady, I disturbed her.
Yes, Doctor. Is there any book recommended to read about this topic in this course? I mean,
Sorry? I was reading something.
Is there any
prerequisite, you mean?
Yeah, Doctor.
No. The only prerequisite is, you know, this course was taught by Dr. Isa Al Hussein long time ago. I studied this course. It was more of a memorization, and we needed to memorize a lot of earthquake. And I try to deviate from this certain type of courses because you will not get something useful. It's better to know how to locate earthquake than when an earthquake happened. So you learn new technique, might be useful to you, the same technique, because that technique used for earthquake can be deployed for something else too. There was a question, if physics needed for this to be, no. You don't need to take any physics because we'll not go too much details into math. If whenever there is a math, because you see the exam and the quizzes and the exam, there will be no involvement of mathematical formulas. But for the practical, because you need to learn something, and you can come back to me and ask me, I can be of help to you. In there, there's gonna be some math. We'll use module, yes. We'll use module for evaluation purposes only. But Google Classroom is the place where I put all the material. I keep putting the material after seeing that everyone is settled and is not trying to go back and come back to the same course. So by the end of this week, I think everyone is he's made his mind whether to stay or not in my course or some other courses even.
Doctor.
We have some concern about the Python program you said.
Whenever you have any concern about the Python program, I will try to rectify your concerns. I try to
Because we didn't use it before, and how we are going to use it anyway? You will give us the access to the computer of the science college.
No, I ask you to install Python yourself. Do you have a laptop at least? You need a laptop.
Yeah, I have a laptop.
Yeah, that's fine. That's way better than using some other computers. So I send you the details today or tomorrow to install Python, because we're going to have the first lecture we have for the first lab is an introduction to Python and how to use OpsPy, how to install OpsPy, not into the details, just how to use Python.
Doctor,
Free or?
Huh?
can we use a Spark instead of this program? Spider.
Spider is Python. Yes, Spider is Python.
Okay.
Yeah, it's the same. Python is the language, Spider is the environment. Yeah, we'll be using Spider, don't worry. Good point, thank you. What is the enrollment key? I will send it to you. Let's everyone settle down because I'm not sure whether you stay or not. Ahmed is asking. Is there any book? Yes, there is a book, but I don't recommend to go to that book because there is a lot of math involved in that book. So the book is routine data processing in earthquake. So if you go back here, what happened? That's the book. You see, I'm following the same structure, but I don't want to go to the details in terms of math. And I want to simplify it much more. So the book itself is quite condensed. So when I was talking about, you see, phases, seismic phases, those are all seismic phases. Do you need to remember all of them? No, never ever. I can't remember them. So this is the book itself. Those are the travel times. You need to know all these travel times? No, they are not necessary, but at least to get some idea. So this is the book itself. But I prefer that you follow the tutorial handouts, lecture notes. Let's see if is there any book. Any more questions? So there is a book, yes, but I don't recommend to waste your time probably or go into the details because the course is way simpler than this book. The course is supposed to be way simpler than this book. Any more questions?
We have a request.
What's that?
هذا الفورتي مال شو اسمه الفاينل is it fixed يعني? You can't separate it for something else?
Yeah, we can change it. But
Yeah, please, because 40 is a lot.
Final exam, you mean?
Yeah.
Okay, so for the final exam, here how it works. Everyone should agree, and everyone should give me the signature. You know why? Because some times ago, some instructors, they changed the exam, and there were some students who were not in agreement, and they haven't attended the exam. This might create...
No, doctor. I mean, يعني total weight of the final exam.
Okay.
40.
Is it too much?
It is a lot. Yeah, because يعني we have quizzes, we have project, يعني technical شو اسمه part, and this is أحس هو اللي يطلع قدراتنا أكثر عن الفاينل exam.
Okay, let's agree on that right now. Let me do something in here. Let's agree on that point. What about 30 and the practical is 20? Do you see that one? What do you think? We make quizzes 10%, practical, this is the lab part, homework, in-term exam, mid-term exam 20, and the final exam 30%.
That's all right for me.
Are you agreeing, all of you? I make a pool.
Yeah, it's quite better.
Okay, I will make a pool asking you to agree on that, but it's fine. According to the SKU regulation, but they are more like reluctant nowadays. Nowadays, because where the teaching is online, and it happened that last semester some exams were cancelled. You know, some exams were cancelled. The reason is that the examiner, the instructor, thought there were some cheating in the exam because the grades were so high. Yeah. So maybe making more practical is better for you than final exam. Yeah, that's how is it. Another thing, you can contact me through my phone if you like, anytime. So my phone number 952525592. This is my phone number. If you would like have any concern, but don't call me through WhatsApp only. Okay? You can chat me through WhatsApp.
Doctor,
Yes. Yes.
about the final, does the final include all the materials
No, whatever
we
covered in
learn
the
the
midterm will not be
beginning
included
to the
again.
end?
That's my system. Whatever
What?
included in the midterm will not be included again in the final.
That's fine.
Yes.
Thank
Some students, they have taken some courses with me last time, they know that. So the final exam is exclusive, the material exclusive of what have been already examined in the midterm. Again, the timing of the midterm is not finalized. I made it on week 8 on Tuesday, the lab time. But in case you think that it's conflicting with other courses you have, we are flexible to change it. Any more questions? We are running out of time. I don't want to delay you much more.
Yes, doctor, about the homework.
Yes.
What is the nature of it? How
Good
we can
questions.
do that?
I send you the homework in term like a Word document, and you you try to answer those questions. Those questions not necessarily writing answers. You do something with OpSpy and try to solve that the problem you have through OpSpy. But usually,
So this is during lab season?
no, after the homework or after. You have like 1 week or 2 weeks. It depends on.
Okay.
Yes, but after the lab sessions, you also need to attend the lab sessions because there is an evaluation by any course needs to be an evaluation system. And one of the best evaluation system is giving the students homework and lab sessions. This is the system actually more often deployed or used in UK. You find the weights they give to the final exam is very small, but the weight they give to the labs and exercises and homework is like 70 or 80%.
Doctor,
Yes.
there is any group work here, or it is individually? I mean the practical side.
You can work in groups, no harm at all. But everyone's supposed to send. Let's see how it goes. Maybe it's gonna be easier for me to mark whenever you just send me as a group one report rather than everyone sending a report. But no, let's see how it goes. For each lab, for each homework, I tell you what is the procedure for that one. Is that fine?
Yeah, yes.
So there is no harm at all if you work as a group. You discuss with each other. There is no lab final. No lab final. No final lab or exam for the labs. They are just practical, as I said, 20% and homework or assignments. You can submit within a week or 2 weeks. It depends on
لو
the.
سمحت دكتور،
Yes.
هل في إمكانية إنك تغير تاريخ الفاينل إكزام؟ لأنه بيصادف في معنا اختبار مادة ثانية في نفس اليوم.
تكلمنا عن الموضوع. الحين حد سأل، أتذكر واحدة بنت سألت، خبرت أن أنا بنفسي ما عندي مشكلة، الطلبة كلهم مفروض يوافقوا ويوقعوا نفس الشيء، لأنه حصل كذا مرة الدكاترة غيروا فاينل إكزام وكذا طالب ما حضروا وتمشكلوا الدكاترة مع الطلبة. يعني
زين، هل في إمكانية إنك تسوي ذا الأسبوع عشان نعرف يعني وضعنا، هل بنحذفه أو بنخلي، لأنه بيصادف اختبارين في نفس اليوم، فاينلين يعني.
والله بيدكم هذا الحين، أنا ما أقدر أقول لك أيوة ولا لا. يعني أتفق الحين على يوم أختار بنفسي يوم وبعدين حد ما يوافق الأسبوع القادم، فصعب علي أقول إنه خلاص من هذا الأسبوع أنا أختار يوم. صعب جدا أخوي، لازم بنفسكم توافقوا. فاعتذر منك يعني ما بيدي ان هالاسبوع اخبرك هل ممكن خلاص نحدد موعد اخر اختبار متى فاينل اكزام متى يكون. لا صعب.
الأمور طيب.
That's how is it. So as I said, there were cases the final exam some students haven't attended and the instructor went into big trouble because the final exams they are not decided through the instructors, through the SQ system, and we're supposed to to follow those rules, stick to those dates as well. But in case you agree yourself, because I made a change last time for my students, but they agreed, all of them. They signed and sent me a paper, oh, we don't have a problem changing the exam. That's fine for me then, because whenever I get into trouble, I show them that letter with the signatures. All those students, they made a change, I followed their request.
Doctor,
Yes.
can we use Aconda instead of Spider?
شوف Anaconda brings spider. You have to use Anaconda. Anaconda هو بايثون يعني. أنا أوضح لكم يعني شوف بايثون هو البرنامج. Python itself is the program, is the brain which works. Anaconda يعني سابقا قبل يمكن 10 سنوات بايثون بدأ يشتهر يعني حاليا بايثون. وانا نصيحتي يعني انت ما دام انك اير ساينس ولا انجينير you have to learn some programming. There is no option at all. You can't say, oh, I'm geologist, I probably better be away from programming. No at all. Nowadays يعني during this pandemic every market went down. The only market was booming is technology and programming. There were enough jobs and there will be plenty of jobs in programming in the coming years. And like AI technology, big data, this new technology, they all depend on programming. If you know at least some programming, and by the way, يعني Python is the front end of these things. Python is the front end of this AI. I'm not sure whether you heard of these things, these terminologies, but nowadays AI, big data, artificial intelligence, they all depend on Python. You need at least to know some programming. Either, for example, you say, okay, I go to join oil industry. Yeah, you might use a built-in program, but you cannot trust a result if you don't see how it works, especially for science and engineers. You need to know at least some programming. For geologists, you create amazing maps, either using Python or other programming. Python is easy, or even MATLAB. Engineers, they use MATLAB. Why I'm going through Python? Because it's free. You can install it at your home. And it comes packaged with all the necessary tools for scientific programming, like doing scientific things. OpSpy is scientific built. You say, okay, I need Anaconda. Anaconda هذه الشركة ايش سوت؟ سابقا بايثون كان صعب انه واحد ينزله يثبته على ويندوز. انه هو built the libraries built for Linux. So it was easy to build it, to compile it for Linux. So some people, they built Anaconda company. They said, let's make Python as one package and bring all the scientific libraries like OpSpy, other packages. OpSpy is scientific package in Python. It's using Python language. So we'll use Python. And Spider is the interface. It lets you write the codes. It lets you see the results. It lets you to plot. The plotting is done by some other packages, but Spider is the front end. It lets you write code. مثل النوتباد. سمعت عن النوتباد؟ Yeah. So this is same as Notepad. لكن Notepad is very simple. Spider is advanced. حتى يخليك تكتب كلمة ويعطيك التكملة بنفسه.
بس دكتور بس ما يفرق لو استخدمنا باي تشارم أو استخدمنا سبايدر، صح؟
Sorry? PyCharm you need to use?
ما يفرق
ما يفرق ما يفرق.
Yes. ما يفرق صح؟
I use PyCharm, but PyCharm is يعني for some students very heavy. by heavy يعني بعض الكمبيوترات إذا كمبيوترك ضعيف تحصل إنه يعلق عليك. PyCharm ثقيل جدا. فإلا إذا كان كمبيوترك قوي وجديد والرام فيه قوي فعادي تروح للبايشارم. أما إذا بتنزل أناكوندا تثبت أناكوندا السبايدر يكون موجود فيه على طول من الأول، ما يحتاج إنك تثبته. فعشان ما تعبكم أعطيكم أشياء زيادة خلاص ثبتوا أناكوندا. برسلكم كيف تثبتون أناكوندا. نستخدم أناكوندا من الأسبوع القادم وعلى طول نروح نعطيكم نبذة عن البايثون وإيش البايثون. لأن حتى اللي يدرسون حاليا يمكن جيولوجيست ما ياخذوا، لكن جيوفيزيست وحتى تخصصات ثانية بديهيات البروجرامينج أشياء جدا ضرورية. يعني أشياء حتى الجيولوجيست مفروض ما يقولوا إن لا إحنا جيولوجيست ما نريد نتعلم بايثون أو أي لغة برمجة. الجي اي اس أغلبه يعتمد على البرمجة بعد يعني. والمابينج نفس الشيء. إذا تريد تسوي maps clear good scale maps you need to use a programming language. If you use not everything is free يعني. If you want to save money don't be a person who wants to spend his money for nothing. You might open a company someday and you think okay I have a plenty of money in a country which is very rich. Should I go and get packages which has like not commercial packages instead of open source packages? Python is open source, it's free. You can see the codes, you can see it, you see everything. That's my recommendation than using Python. But we'll not go into the details. We just I used OpSpy a lot for my PhD يعني. They are advanced things and they are basic things. We go through the basic things. We don't need to develop something new, but use whatever is already available. I exceeded my time limit. I don't want the students to stay if the time limit is exceeded. Maybe it's first day, maybe you have some enjoyment or excitement to come to the university, begin your semester. But you are free to leave, and in case if you have any questions, you can ask me through my email or send me a WhatsApp message or even a general discussion message. Then Google Classroom is open for any discussion. You can write whatever you have in your mind. Any more questions, or shall I discontinue or disconnect the streaming? Goodbye.